Hello everyone, welcome to my YouTube channel Physics Numericals. Learn to solve numericals step by step in an easy way. Today, let's solve PYQs of JEE Mains 2025, and today the questions are related to chapter Gravitation. So, let's start. Question 1 is, a small point of mass m is placed at a distance 2r from the center O of a big uniform solid sphere of mass m and radius r. So, in this question, you can see in this figure, we have a big uniform solid sphere whose mass is m and radius is r. And a small point mass m is placed at a distance 2r from the center O of the big sphere. You can see this total distance is 2r, and this distance from here to this place, this is the radius r of the big sphere. So we can say that this point mass is also at a distance r from the surface of the sphere. Now, next, the gravitational force on m due to capital M is F1. इस small point mass P जो 2r distance पर है from the center of the big sphere, इस पर जो force लग रहा है इस sphere के चलते, bigger sphere के चलते, वो F1 है. ये question में दिया हुआ है. A spherical part of radius r by 3 is removed from the big sphere as shown below. You can see in this figure a smaller spherical part whose radius is r by 3. This is given in this question. This small spherical part is removed from the big sphere of mass m. So we can say that this small spherical part will act as a cavity. Next, the gravitational force on m, small m, due to remaining part of capital M is found to be F2. अब इस क्वेश्चन में कह रहा है कि जब इस स्मॉल स्फेयर को इस बिग स्फेयर से रिमूव कर लिया गया, तब जो फोर्स पॉइंट मास m, स्मॉल m जो है, जो पॉइंट P पर है, वहाँ पर जो फोर्स लग रहा है इस रिमेनिंग स्फेयर के कारण, वो F2 है. So we have two forces F1 and F2, and we have to find the value of ratio F1 is to F2. So we will solve it. First of all, we will find out the force F1 which is acting on the point mass m due to the big sphere of mass capital M. So we know F1 will be equal to, if the distance between these two masses capital M and the small m is equal to 2r. So we can write that the force F1 is equal to G m. Capital M is the mass of the big sphere, and small mass m, which is a small point mass which is placed at a point m, P, which is at a distance 2r from the center of the big sphere. So the distance is 2r, and squaring it, we will get F1 is equal to GMM by 4r square. तो हम लोग ने F1 निकाल लिया. नेक्स्ट हम लोग को पता करना है कि F2 कितना होगा, क्योंकि हम लोग को फाइंड करना है रेशियो ऑफ F1 इज टू F2. अब ये फोर्स F2 किसका है? जब ये स्मॉल स्फेरिकल पार्ट इस बिग स्फेयर से रिमूव कर लिया गया, तब जो स्फेयर बचा, जो रिमेनिंग स्फेयर है, उसके कारण जो फोर्स लग रहा है F पे, ये पॉइंट P पर, उसको फोर्स F2 बोलते हैं. तो वो निकालने के लिए पहले हम लोग ये निकाल लेते हैं कि ये स्फेरिकल पार्ट जो है ये कितनी दूरी पर है इस पॉइंट मास से. तो हेयर द रेडियस ऑफ स्मॉल spherical part which is removed from the big sphere, the radius of this small spherical part, it is given in the question, is equal to r by 3. So center of the small spherical part is this place, and this distance is the radius, which is r by 3, and the distance of this point mass m from the surface of the bigger sphere is r. So finally distance between the cavity, we can say cavity, the spherical part which is removed, between cavity and the point mass m is equal to r by 3 plus r, which is equal to 4r by 3. So force on point mass m due to the spherical part which is removed, we can say due to cavity, is equal to g. Now mass of the this cavity we have to calculate. Suppose the mass of this cavity is mc, multiply mass of the point mass m, and the distance between these two is 4r by 3. So squaring it. So for finding the force on point mass m due to cavity, we have to find out the mass of the cavity. For finding it, we have to use the relation that for solid sphere, it is given in this question that this is a uniform solid sphere. So for solid sphere, which is a 3D figure, we know mass is directly proportional to volume. Or we can say that mass is directly proportional to r cube. So we will use this relation to find the mass of this small spherical part which is removed from the bigger sphere of mass m. So mass is directly proportional to r cube. If suppose r1 represents the mass of the small spherical part which is equal to r by 3 given in the question, and capital R we know is the mass of the bigger sphere. So we can write m by m, which is the mass of the bigger sphere, divided small m, which is the mass of the point mass, is equal to r cube by r by 3 का whole cube, which is equal to, so from here we can write m is equal to capital M multiply r cube by 27 into r cube. These two will get cut, is equal to m by 27. So this m c represents the mass of the small spherical part which is removed. We will put this value in the equation 1, this place, and by putting this value we can find out the force on point mass m due to the spherical part which is removed. So force due to spherical part which is removed on point mass m is equal to g multiply m by 27 multiply small m, which is the mass at this place at the point P, divided 4r by 3 का square. So it will be equal to 16 r square by 9. So finally it will be equal to g m divided, these will get cut, divided 48 r square. Now we have to find F2, which is the force at this point P due to the remaining sphere when this spherical part is removed? So that we can find out when we subtract the force due to the big sphere minus the force due to the spherical part, small spherical part. If we subtract these two, we can find out the force or at the point P due to the remaining sphere. So force due to the big sphere, just now we calculated, is equal to gmm by 4r square. So F2 is equal to gmm by 4r square minus gmm by 48 r square. This is the force at the point P due to the small spherical part which is removed. When we subtract it from the force due to the big sphere at the point P, we will find out the force F2, which is the force due to the remaining sphere. So let's calculate. It is equal to G capital M small m by R capital R square 1 by 4 minus 1 by 48, which is equal to G M capital M small m by R square 11 by 48. Now we have to find ratio of F1 by F2. So F1 is gmm by 4r square, gm capital M small m by 4r square, and F2 just now we calculated is equal to gmm by r square 11 by 48. So all these will get cut. Finally we have 1 by 4 multiply 48 by 11. This will get cut. Finally, the ratio F1 is to F2 is equal to 12 is to 11. So, this is the answer. So, this one, third one is the answer. Now, next question. A satellite of mass m by 2 is revolving around Earth in a circular orbit at a height of r by 3 from Earth's surface. The angular momentum of the satellite is capital M root under gmr by x. The value of x is, we have to find the value of x in this formula, where capital M and r are the mass and radius of Earth respectively and capital G is gravitational constant. तो इस क्वेश्चन में एक सैटेलाइट है जिसका मास m/2 है, वो रिवॉल्व कर रहा है अर्थ के अराउंड. अर्थ का मास कैपिटल M है और रेडियस r है, और वो सैटेलाइट जो है वो अर्थ के सरफेस से r/3 हाइट पर है. सो लेट्स ड्रॉ इट. Suppose this is Earth of mass m and radius r. Now there is a satellite which is, the satellite is at a height of r/3 from the surface of the Earth. And the mass of this satellite is m/2. So, we have to find the angular momentum of the satellite. First of all, Earth is of radius r, and r/3 is the height from the Earth to the satellite. So finally the distance of the satellite from the center of the Earth will be the radius of the satellite. So radius of satellite is equal to r plus r/3, which is equal to 4r/3. Also, mass of satellite is given in the question is equal to m/2. Now we will calculate orbital speed of satellite. We know the formula to calculate orbital speed is equal to root under capital G, capital M. M represents the mass around which the satellite is revolving, and this is the mass of the Earth, divided the distance of the satellite from the center, and which is 4r by 3. So orbital speed is equal to 3 gm by 4r. Now we know angular momentum is, if we represent it by L, it is equal to mvr. M represents mass of satellite, V represents orbital speed, and R represent radius. So we will put the values. So mass of satellite is m by 2, orbital speed is root under 3 gm by 4r, and radius of satellite is 4r by 3. Now we have to arrange it such that it is equal to this given m, capital M, root under g m r by x, and we will find out the value of x. So we can say L is equal to m root under 3 gm by 4r. This 2 will come inside and will become 4, and these 2 will, this will come inside and will become 16r square by 9. So finally we have L equal to capital M root under gm r square by, this r will also get cut, gmr by 3. If we compare this with the given value of angular momentum, we can easily find out that the value of x is 3. So this is the answer. Now next question. Earth has mass 8 times and radius 2 times that of a planet. If the escape velocity from the Earth is 11.2 km per second, the escape velocity in kilometer per second from the planet will be. So इस क्वेश्चन में दिया हुआ है कि एक प्लैनेट है, उसके मास का 8 टाइम्स मास अर्थ का है और उस प्लैनेट के रेडियस का 2 टाइम्स रेडियस अर्थ का है. अगर escape velocity अर्थ का 11.2 किलोमीटर पर सेकेंड है तो हम लोग को पता करना है कि escape velocity उस प्लैनेट का क्या होगा. सो फर्स्ट ऑफ ऑल लेट मास ऑफ planet be m and radius of planet be r. Then according to this question, Earth has mass 8 times of a planet and radius 2 times of a planet. So mass of Earth will be equal to 8m and radius of Earth will be 2r. Now we will find out for Earth. We know that the formula for escape velocity is v is equal to root under 2 gm by r. So putting the value, the mass m, this small m represents the mass of Earth. For Earth it is equal to 8m. So we will put the value for Earth. For Earth, escape velocity is equal to root under 2g 8m by 2r. For planet, escape velocity will be root under 2gm by r. Now we have to find the escape velocity for the planet. So this is equation 1, this is equation 2. We will divide these two. We will get, if we divide the escape velocity of the planet, escape velocity of planet by escape velocity of Earth, we will get root under 2gm by r divided root under 8gm by r. So finally it will get cut, and we will have root under 2 by 8, which is equal to 1 by 2. So escape velocity of planet is equal to half. This will get that side, and we will multiply the escape velocity of Earth, which is given in this question, 11.2 km per second. So finally the escape velocity of planet is equal to 5.6 meter per second. That is this one, 2. Sorry, this is kilometer per second. Now next question. Two planets A and B are orbiting a common star in circular orbits of radii, Ra and Rb respectively, with Rb is equal to 2a, 2Ra. The planet B is 4√2 times more massive than planet A. The ratio Lb by La of angular momentum of planet B to that of planet A is closest to integer. So again in this question we have two planets which are orbiting a common star. So let's draw it. Suppose it is a common star of mass m and radius r, and we have two planets, planet A whose mass is suppose ma and radius is Ra, given in the question. Now there is one more planet which is revolving around it, whose mass is given in this question is 400. Planet B is 4√2 times more massive. So suppose if Ma represents mass of planet A, then the mass of planet B will be 4√2 ma. Also radius Rb, the radius of the planet B, its relation is also given in this question, that it is equal to 2Ra. So Rb is equal to 2Ra. These are the information which is given in this question, and we have to find the ratio of the angular momentum of planet B to that of planet A. So let's calculate. For planet A, we have mass is equal to ma, radius equal to Ra, and orbital speed of planet A will be equal to root under gm by Ra. Then angular momentum for planet A, if we represent by La, then La is equal to ma Va. Va represents orbital speed of planet A, and Ra represents the radius of planet A. So we have MA root under GM by RA and RA. Next, for planet B, mass is equal to 4 root 2 of MA, 4 root 2 of MA. Radius of planet B, RB, is equal to 2RA given in the question, and orbital speed of planet B, if we represent it by VB, it is equal to root under G. Now mass is 4 root 2 MA divided radius is 2RA. So this is equation 1, this is equation 2. Now we have to find the ratio of these two angular momentum. So LB, which represents angular momentum of planet B, by LA, which represents angular momentum of planet A, is equal to 4 root 2 MA VB RB by MA VA RA. We will put the values of these two orbital speeds. Now this MA will get cut. 4 root 2. Now in place of RB we can write 2RA, and VB is equal to root under GM by VB is equal to root under GM by 2RA. Now this place, this is not 4 root 2 MA, this is capital M. So VB orbital speed for planet B will be equal to root under G capital M by 2RA, where 2RA represents the radius of planet B. So then we will write the orbital speed of planet A, and it will be root under RA by capital GM. Finally, these all will get cut, and we have 4 root 2 multiply 2 multiply 1 by root 2. These two will get cut, and finally answer is 8. So the ratio of angular momentum of planet B to that of planet A is closest to integer 8. This is the answer. So that's all for today. Thank you.